Section 1-12 deals with logarithms and exponential functions. So let's look at a couple of examples of those really quick. So we've got our exponential. So exponential kind of looks like y equals e to the x. So e is, approximately 2.7. So don't freak out about it. It's just a number, just about similar to pi, that has special properties that are very unique in calculus, and we will use this quite often. So this e to the x sort of looks like this, right? It begins all the way down to negative infinity. It has values that go as high as possible, but notice that its domain is infinite, right? We have every domain option, and its range is anything above 0, and that's really important when we talk about stuff later. It does have a horizontal asymptote at y equals 0, so it is never ever going to reach that number. Okay, so then we have our logarithmic functions. So these are going to look like y equals log of x, or y equals the natural log of x. The difference between those, I'll explain in a minute, is that logarithms are actually exponents, and it's a way for us to solve for them. They are, in fact, whatever the inverse of the exponential function is. So logarithms look usually something about like this, right? They sort of kind of invert what's going on with e to the x. You see how e to the x kind of starts, goes up. It's a little different. Logarithms actually, they're allowed to, the value of the logarithm could be anything. However, we can't plug everything in. We notice that there's a vertical asymptote at x equals 0, and that means that we could never plug 0 into a logarithm. We could never plug a negative number in either. And so we'll gain some more familiarity with these as we move along, but the main thing with logarithms is that they can have different bases. The natural log always has a base of e, and the regular logarithm can have a base of anything. Normally, if you don't see any number, it's base 10, but it could be anything. So let's talk about a couple of the rules with logarithms, because again, they behave like exponents, so it's a little different than other things. So we're going to work on simplifying and how we work with these as we move along. So the first one is the log of x plus the log of y can always be simplified as the log of xy. So by adding logarithms, so think about adding exponents, that actually occurs when we multiply bases together, and so that's why it's the log xy on the other side. Similarly, the log of x minus the log of y equals the log of x over y. So, and if you think about going back to exponents, if we subtract exponents, that means we're dividing. So that's how that comes about. And then finally, if we have y times the log of x, so we have y logs of x's, that actually means that we have the log of x to the y. So these are the only 3 rules that work with logarithms. We're very tempted to try to make other ones make sense, but these are the only ones that work. So we can always simplify from going from the left side to the right side by either multiplying the insides of the logarithms, dividing them, or raising them to new powers. So that being said, there's a few other possibilities that we can see, and that comes about when we are trying to do inverses of things. So I will kind of explain how that works here in just a second. So we'll start with the natural log first. So y equals the natural log of x. Well, this can be rewritten in the same sort of fashion as this. So the natural log has a base of e. It's e to the y equals x. So it's the inverse of y equals e to the x, is what the natural log function does. So what happens is that one property emerges which is really neat. And that is that if we say that the natural log of e to the x, okay, the natural log of e to the x is x. Okay, sorry about the interruption there. So this is if we take a natural logarithm of e to the x, it kind of undoes e. It allows us to solve back for x. So the way, again, you can read this is that a natural log has a base of e to the x equals e to the x. So just think of, if we have the natural log of e, it kind of undoes it. It makes it simpler for us. Likewise, another thing that also works is that we have e to the natural log of x equals x. So they undo each other in both ways, which is very nice. So that allows us to solve for all sorts of different stuff and simplify kind of some very crazy looking logarithms. So logs work the same way. So normally we have a log base 10, but let's say I'm going to say log base 3 of 3 to the x equals x. So just like the other one, right? So natural log just always has a base of e, where a regular logarithm could be anything. Likewise, if we have 3 to the log base 3 of x, that's going to equal x. So this is something like, that we can undo and to simplify things as we kind of further go along. So these are good rules to know. And lastly, I want to talk about domain very specifically. So with domain, we have, let's say, y equals e to the x. This is going to be all real numbers. So we can plug any number we want in. We can plug in negative a billion if we want. Right? That's just going to give us a really, really tiny positive number. So, like, our domain is going to be everything. Our range is going to be all positive numbers. Now, when we deal with y equals log of x, the domain is always going to be like this, right? It's going to be x has to be greater than 0. Whatever goes in the inside of a logarithm has to be positive. It is not allowed to be negative ever. So this is very important when we go and we think about functions moving forward, that whatever goes in there has got to be positive. Let's see. Now, likewise, they're going to ask some other questions later on. Again, remember, for domain, we still cannot divide by 0. And an even square root, x has to be greater than or equal to 0, right? Whatever goes inside a square root, unless it's, this is an even root. Now, if it's an odd root, then x can be all real numbers. Or I'll just erase this part. So we can have all real numbers there. So that's a big difference, right? If I have an even root versus an odd root, it's very, very different. So it allows us to plug in different things, especially with an odd root. If you can think that, a negative number cubed is still negative, well, that's why this happens this way. We can take the cubed root of a negative number, but we cannot take the even root of a negative number. So we're going to work along with this next time, and so hopefully we'll have some good success.